Ding. Asa na to kung yun istorya? Diuretic to, no? So, sodium acetate. Now, the second one is urinary alkalizer. So, from the name itself, alkalizer, meaning yan, if we are going to consume the sodium acetate, our urine, sa ating urinary tract, in the environment and then the urine itself will become alkaline or basic. Okay? So, merong mga instances that we need to make the urine alkaline. For example, in the case of poisoning. Example na poison ang person ng acid. Okay? Acidic na substance like nag-consume ng maraming vitamin C or ascorbic acid, naglaklak, isa kapad, giinom ka isa. So, you know, from the name itself, ascorbic acid, it's an acid. Now, pag ganon yung nangyari, we are going to make the urine alkaline. Okay? Kasi 'di ba, ganito, neutralization yan siya ha. 'Di ba pag merong acid tapos nasa basic environment siya, ano nga products nito? Let me see kung nakalimot na ba or wala. Ano nga products nito? Acid plus base is equal to? Yes. Okay, Mr. Baganyan.
Water and salt, ma'am.
Okay, water and salt. Or salt and water. Yan. Na ganito na ha. If you have consumed, for example, a lot of acid and then you will be making the urine alkaline or basic, syempre mag-result yan siya sa water and salt. And it will be excreted sa urine. Because remember, salt is water soluble. Our urine is most likely made up of water. So yung salt na mapo-form dyan will be dissolved in the water in the urine, and then again, it will be excreted during urination. So mas mabilis ma-excrete yung na-consume na maraming acidic na substance. So yan yung example of a condition wherein we are going to use a urinary alkalizer. Pero hindi yan lahat ng acid ha na gagawin nating basic yung urine. Pero ganito ang tandaan nyo, if ever mag-consume ma-poison ang person with a strong acid. Example, ang nainom is hydrochloric acid. And you know that hydrochloric acid is a strong acid. One thing that you need to remember, class, do not neutralize. Again, do not neutralize. What do I mean by do not neutralize? Pag nakainom siya ng strong acid, wag niyo inuman ng strong na base, ha? Hindi strong base yung antidote for that. Ang tawag kasi dyan, pag nakainom ng strong acid tapos binigyan yun ng strong base, boot siya. It's double kill. Okay? Kasi nga, strong acid yun. Pag nainom yun, pag napunta sa esophagus, sunog ang esophagus. Tapos nag-inom na pod og strong base, sunog na po. So because second time around nasunog ang esophagus. So yan yung sinabi ko na do not neutralize. Huwag niyo sundan ang strong acid ng strong base. You may make the urine alkaline, but please take note that sodium acetate kasi is a very weak base. So hindi talaga siya maka-neutralize ng acid doon sa esophagus banda or sa gastrointestinal tract, but it's more on the urine para pag nagkaroon sila ng interaction, again, there will be the formation of the water and salt, and these products are easily excreted, okay, para malabas yung kung anumang acid ang nainom. Now, since sabi ko kanina, it's a weak base, ang sodium acetate. So, syempre, we can use this one as antacid. Also, when you say antacid, it's anti-acid. So, from the name itself, antacid, anti-acid, please take note that this is used for conditions with too much acid in the stomach. So just like hyperacidity or yung sa mga cases na merong ulcer or merong GERD. GERD is gastroesophageal reflux disease. So when you say GERD, yan yung magre-reflux, babalik yung acid pataas. Ha? That is the use or that is where we use antacid, sodium acetate. That we have a lot of antacid in the market. You cannot actually see sodium acetate in the market na sodium acetate lang. Okay? We mostly use other antacids. Ano ba other antacids that you know? Ngayon yung hang ginainom. Or nagainom ba mo antacid? Or like someone you know? Ako, I'm a consumer. Grabe na mag-consume sa antacid because I have hyperacidity. I have a very sensitive stomach. If I'm going to consume a lot of acidic foods or even fatty foods, I'll be having hyperacidity. So, I consume a lot of antacid. Wala mo nagainom mo antacid. Sana all. We have a lot of antacids in the market. We have Kremil S, we have Simeco. Yeah, Kremil S. But when you say Kremil S, ang laman yan, I want to write sa screen. We have aluminum hydroxide plus magnesium hydroxide. Na-mention ko na sa inyo ito, diba? And then the simethicone. The simethicone there is an anti-flatulence. Yes, Marley. Are you raising your hand?
Ma'am, paano unsa ng omeprazole, ma'am?
Omeprazole is a proton pump inhibitor. That's the name ha, proton pump inhibitor. Proton is actually hydrogen. It represents hydrogen. So in our stomach class, we have a pump that produces hydrogen. Okay? Kasi ganito, yung ating gastric juice, yung gastric acid natin is HCl, sorry. It's hydrochloric acid. And before yan siya mabuo, syempre kailangan mo ng hydrogen. Aside sa chlorine, kailangan mo ng hydrogen. Yan yung trabaho ng pump. Nagpo-produce ng hydrogen para mabuo ang HCl. Now, pag mag-consume tayo or mag-take tayo ng omeprazole, aside from omeprazole, we also have pantoprazole. Makikita mo naman yan sa name, mag-end yan sila sa prazole. Pantoprazole, esomeprazole, ganon. They are proton pump inhibitors. They will inhibit the pump that produces the hydrogen. Kasi syempre, pag walang hydrogen, hindi mabubuo ang HCl. And walang acid. So, they are not called antacids kasi pag sinabing antacids kasi direct sila doon sa acid. In-neutralize agad nila yung acid just like the sodium acetate or itong components ng ating Kremil S, the aluminum hydroxide, magnesium hydroxide, and simethicone. Ito silang tatlo, actually dalawa lang, aluminum and magnesium hydroxide. Diretso kasi sila sa acid, meaning nabuo na yung acid. Example, the patient is experiencing hyperacidity. Nabuo na yung acid. Pag ininom natin ito, ino-neutralize diretso yung acid na yon. Si proton pump inhibitor kasi, doon siya sa prevention of the formation of more acid. So, pwede mo din siyang ibigay for people with ulcer or for people experiencing GERD para wala nang more, hindi na madagdagan yung acid in the stomach. Yun yung gamit ng mga prazole. Again, we call that proton pump inhibitor. Si Gaviscon is an antacid. Okay? Again, si Gaviscon is an antacid. So, diretso yan siya mag-neutralize sa stomach acid natin. But it contains a different substance. It contains sodium alginate. So, iba din yun siya. Meron tayong sodium acetate, aluminum and magnesium hydroxide. At the same time, on the screen, you can see the sodium bicarbonate. Sodium bicarbonate is also an antacid. Okay. Actually, it's a systemic antacid. We can absorb sodium bicarbonate and then since maabsorb siya, mapunta siya sa blood, our body will become alkaline or basic also. So that's how strong the sodium bicarbonate is. We have sodium bicarb in the market. If you're going to work in the pharmacy, meron tayong sodium bicarb dyan na binibenta. Antacid yan siya. Okay? But actually, it's not just seen in the pharmacy. Sodium bicarbonate is known as the baking soda. So from the name itself, baking soda, ginagamit niyo ito during baking. I don't bake, so I don't know. I don't know kung ano talaga, I mean, paano siya ginagamit sa baking. Papatubo niyo siya, no? But again, that is the baking soda that we know, the sodium bicarb. Kung sa industrial na use, pero kung sa pharmaceutical na use, it's an antacid and at the same time a carbonating agent. So as a carbonating agent class, ano ito siya, both pharmaceutical and industrial use. Number one, pag sinabing carbonating agent, it's a source of carbon dioxide. Pag nilagay mo ito sa preparation, it will cause the release or the liberation of carbon dioxide. And the purpose of that is actually for palatability. When I say palatability, para lami imuhang ginainom. That's it. So sa industrial na use, example sa mga carbonated drinks natin, like Coke or Sprite, example, nilalagyan yan siya ng sodium bicarb para ma-release yung carbon dioxide. Actually, sa kanila, carbon dioxide na diretso. But if they're going to use the sodium bicarb, carbon dioxide will be released. And that gives the taste sa Coke na, anong tawag yan? Sparkling taste. That's how you describe the taste ng mga carbonated drinks natin. Sparkling taste. Pag nawala ang carbon dioxide sa carbonated drinks natin, tamis na lang, mura kag niinom og tubig nga gibutang og asukal. Mawala yung espiritu. Okay? So mo na siya na ang tawag dyan, kailangan may carbon dioxide para lami ang ginainom. It's normal. Makasuka? Pwede. Pwede siyang like adverse effect of the drug. Pwede siya. Normal. Normal na siya. Sige. Now sa pharmaceutical na side class, please take note na meron tayong ganito, effervescent preparations. I don't know if you have heard about this, but I believe you know this. Effervescent preparation, ito yung mga pharmaceutical products natin na pag nilalagay sila sa water, and then 'di ba nag-release sila ng bubbles, nagli-liberate sila ng gas. Example, Berocca. Don't know if you have taken Berocca, but it contains vitamins and minerals. Naka-tablet yan siya na malaki. And then if you're going to consume that, you have to place that sa water first. And then pag nilagay mo na siya sa water, magbula-bula na siya. And then pwede mo na siyang inumin. And then it has the sparkling taste. That is because there is still the liberation of carbon dioxide para lami mo hang ginainom. So effervescent preparation contains sodium bicarb or other na mga basic substance. Yes, Marley.
Ma'am, kanang tinod ba na ma'am pag mag-take daw kag Berocca kay maka-help daw na og kanang makakuha gud sa imong pag-study, ma'am?
In a sense, pwede, pero Berocca is more on vitamin C and other minerals. So, pwede siya kung the intended use is to stimulate your brain or to supply your brain with the needed minerals. Pwede naman. Pero kung memory enhancer, I don't think it's a memory enhancer, but then it can help your brain to be active because of the minerals na it contains. Okay? So yun ha, carbonating agent siya. Now, what is our problem with our sodium bicarbonate? Since it's a systemic antacid, meaning pwede siyang ma-absorb in the body, meron din siyang systemic na adverse effect or na side effect. And that is systemic alkalosis. It will increase the pH of our blood. So maging basic yung ating blood pH. And another thing, it can cause rebound hyperacidity. So, pag pharmacist na kayo, pohon, if the patient will consume sodium bicarbonate, this is true for sodium bicarbonate and the sodium carbonate ha, hindi dapat nila i-consume ito ng more than a week. Kasi pag more than a week na tuloy-tuloy yung gamit class, mag-cause na yan siya ng rebound hyperacidity. And when you say rebound hyperacidity, una-una matambalan ilang hyperacidity. Pero since there is long exposure, once they stop using this drug, example after a week, babalik yung kanilang hyperacidity and the intensity is more than that sa kanilang original na condition. So higher ang level sa sakit ani, higher ang level sa sa kadami ng acid na ma-produce. So that's rebound hyperacidity. So again, pag pharmacist na kayo or even ngayon if you know someone taking sodium bicarbonate, please advise them not to take this in a long na exposure like more than 1 week. Okay? Additional use pala of the sodium bicarb is antidote ito for zinc poisoning. So example, nag-consume ng maraming zinc ang ating patient, our antidote is this one, the sodium bicarb, para ma-excrete natin yung excessive na zinc na nainom ng ating patient. Okay, questions or clarifications before tayo mag-move on? Daghan pa ni duha pa lang na siya. Wala. So yes, Maristel.
Ma'am, may notes kasi ako na what is meaning nitong alkalizing agent in Benedict solution, ma'am, sa sodium acetate?
Sodium acetate. Ano yan siya? Alkalizing agent. Di ba, wala pa mo nag-biochem, no? Or nag-biochem na ba mo? Nag-biochem na ba mo? Ang first year, wala pa. Ang mga ireg, nag-biochem na mo?
Wala pa, ma'am.
Okay. Sige. So, yung Benedict's solution, sulat ko ha. Benedict's solution. It's actually a test. It's a solution used to test the presence of carbohydrates, especially the reducing sugars. Again, test yun siya sa reducing sugars. Ginagamit ng example, a person with diabetes class, if we are going to conduct urinalysis sa kanila, meron yan sugar yung ihi nila. Supposedly, wala yan. Wala dapat sugar yung ihi kasi malaking molecule kasi ang sugar, supposedly, hindi yan siya makapass through sa kidneys. But if ever may diabetes kasi, since masyado nang marami ang sugar, syempre nahihirapan na din ang kidneys mag-filter. And thus, makikita ang sugar sa urine. Now, we can do Benedict's test sa kanilang urine. Actually, i-add lang yan siya sa urine. Tapos, ang urine, mag-change yan siya ng color. So, actually, ang urine magiging brick red. Brick red ang color niya. Or, pwede din siya orange. Pwede din siya yellow. Actually, pwede din siya green if konti. Pag marami masyadong sugar ang urine, ito yung magiging color ng test after. Tapos kung intermediate yung amount of sugar sa urine, pwede siya orange or yellow. Pag konti lang, it's green. So again, it's a test used to detect the presence of sugar, reducing sugar. Hindi lang yan siya sa urine ha, pwede sa ibang bagay, pwede sa ibang chemicals. But yung urine example, lang yan siya. Now, si Benedict's solution contains copper, but meron din yan siyang sodium acetate for the solution to become alkaline. Para maging basic, we need kasi na the Benedict's solution is alkaline para we can use it during the test para mabuo yung Benedict's solution. But please take note, yan yung gamit ng Benedict's solution. Okay? What else? Wala na. So let's move on. The third compound for our sodium here is the sodium dihydrogen phosphate. Again, sodium, pwede din sa blood. Yeah, pwede din siya sa blood, pero most likely blood will be positive sa sugar. Meron kasi talagang sugar yung ating blood. It's actually the glucose. Yung problem lang natin, if masyado nang marami ang sugar sa blood, mag-exceed na siya sa normal level. Yun na yung may problem tayo. Pero basically, we can see the sugar sa blood. So talagang mag-positive yan siya sa Benedict's test. Okay? So si sodium, again, number 3, sodium dihydrogen phosphate or NaH2PO4, or this is what we call the fleet enema. We can see this sa sa pharmacy, sa hospital. Fleet enema is used as a cathartic. Okay, when you say cathartic, it's a laxative. When you say laxative, pampabawas. Okay? So, yung ano nito, yung mukha nitong fleet enema, mura ni siyag ka ng sudlanan gani sa toyo. Bali mag-drawing class. Mura siyag sudlanan sa toyo. For example, may club siya anino, and then yun yung merong parang ganyan ang ana. Ganyan yung mukha niya. Ito, ipapasok ito sa puwet, sa anus. And then, ilagay, i-press para mapunta sa loob yung laman. Okay? So again, it's a cathartic or a laxative. We use this for people who experience constipation, pero this is mostly used for people who will undergo procedure in the gastrointestinal tract like colonoscopy or endoscopy. Kasi pag nagganon, di ba, like ipapasok yung camera inside the gastrointestinal tract, kailangan malinis inside para makita kung meron bang something doon sa loob. So talagang ilalabas lahat, yan yung gagamitin. Pwede yan, pero marami yan sila ha. Marami tayong laxative or cathartic in the market. But this is one example of a cathartic, the fleet enema or the sodium dihydrogen phosphate. Pag ginamit mo ito, ubos ang laman ng iyong intestine. And then pag pinasok na yung camera for colonoscopy, for example, wala nang mag-o-obstruct doon sa camera kasi syempre the stool will be an obstruction. And if maging obstruction siya, hindi na makikita ng physician kung anong meron sa loob. Okay? Diabetes. Yeah, pag sinabing diabetes, we have too much sugar in the blood. Mag-exceed yan siya sa normal na level. Kasi supposedly, sugar is used as a source of energy. Pag kumakain tayo, we consume a lot of carbohydrates. For example, starch from the rice. It's a polysaccharide. And then inside the body, i-break down yan siya. I-metabolize yan siya ng body natin. Ang ending kasi niyan, magiging glucose yan siya. That is our physiological sugar. Okay? Mapupunta yan siya sa blood. Pero pag normal kasi ang functioning ng ating body, we will just break down the glucose to make ATPs para meron tayong energy. Ang problema natin, pag hindi na normally nag-function yung body natin, by the way, ma-breakdown yung glucose if we have insulin. Okay? Pag meron ng insulin, ma-breakdown yung glucose, ma-produce natin yung ATPs that we need para energy natin. Pero again, pag example, may problema na tayo sa insulin, yung pancreas natin, that's the organ na nagpo-produce ng insulin. Pag may problema na tayo sa pancreas, example, meron tayong deficiency sa insulin, hindi na kasi natin mabe-breakdown yung ating glucose sa blood. So that is the reason why yung glucose magstay sa blood, pag i-check natin yung blood sugar, mataas. Hindi na siya nag-breakdown kasi kulang ng insulin. So that is what we call diabetes mellitus. Na pag marami na masyado ang sugar sa ating blood, dili po na mamatay diretsyo ha. Yung sa diabetes kasi, that's like killing me softly. Mataas yung sugar nila, pero marami lang siyang clinical sequelae. Hindi agad na mamatay yung patient. Example, since marami yung sugar sa blood, pwedeng masira yung kidneys. Kasi remember, our blood passes through the kidneys. Kasi mag-filter yan siya for like waste materials. And then, I believe nakatry na kayo maggawa ng syrup, ay, di ba? I forgot kung nag-DDS na ba mo. But anyway, example, magtimpla na lang mo og water, lagyan yun ng maraming sugar. Di ba what happened to the water? Maging viscous siya. Magiging malapot because of the sugar na nilagay mo. Ganon din yung blood natin. Pag marami na masyadong sugar, magiging viscous din yan siya. And mahihirapan yung kidneys natin to filter that. So kaya, ang ending, pag people with diabetes, nauuwi siya sa kidney failure. Okay? Marami yan siyang sequelae. And at the same time, the too much sugar in the blood will affect also the nerves. So, yung nerves natin, maapektuhan, masisira yan siya. And that is the reason why pag nasusugatan sila, hindi yan sila basta-bastang nagagamot. Dili sila dali. Sa wound healing, mahirap. Kasi nga, sira yung nerves nila kasi maraming nakadeposit doon na sugar. So, maraming consequences, maraming complications yung diabetes mellitus. Okay? You'll have more of that when you study pharmacology. Yeah, putlon ang TL. Dili naman dyan na siya maayo. It will result to gangrene. Mag-black. I'm running out of time again. Kapuya, magiging sulod balik. Wala tayo mabuhat. Anyway, cathartic ito ha, sodium dihydrogen phosphate. And then this time, sodium dihydrogen phosphate naman is a urinary acidifier. Baliktad ito sa sodium acetate. Kanina, sodium acetate is a urinary alkalizer. It will cause the urine to become basic or alkaline. This time, it will acidify the urine. Okay? Again, it will acidify the urine. So one example of the use of sodium dihydrogen phosphate as a urinary acidifier is if we give the patient methenamine. Methenamine is a drug, ang tawag dyan, it is considered class as an antibiotic. Actually, it's not an antibiotic. It's an antibacterial. It's an antibacterial used for UTI. Okay, ginagamit ito siya sa UTI. Kaya lang si methenamine itself kasi cannot kill the bacteria. So kailangan mo muna siyang i-convert into formaldehyde. Now, pwede mo lang siyang ma-convert into formaldehyde pag acidic ang environment. Kaya siya sinasabay with the sodium dihydrogen phosphate. Since sodium dihydrogen phosphate will make the urine acidic, si methenamine will be converted into formaldehyde. Ito na ngayon si formaldehyde ang capable of killing the bacteria. So for example, meron kang UTI, syempre may bacterial infection doon sa urinary tract mo. Na pwede kang uminom ng methenamine, sabayan mo ng sodium dihydrogen phosphate para si methenamine maging formaldehyde. So si formaldehyde, kaya na yan patayin yung bacteria na nasa urinary tract mo. Okay? So again, formaldehyde yung talagang antibacterial natin. Magiging formaldehyde lang yan kasi siya pag ang pH is 5.5. So remember, 5.5 na pH class is acidic. So that's the work of the sodium dihydrogen phosphate. It's a urinary acidifier. Okay? Now, another one, sodium bisulfate, or we call this sodium metabisulfate, NaHSO3. Plus, it's a water-soluble antioxidant. Okay? It's water-soluble. It's an antioxidant. So, pag sinabing antioxidant, it will prevent oxidation. Okay? So, maraming gamit ang antioxidant. Pharmaceutically, ang mga pharmaceutical preparations natin or formulations, nilalagyan yan siya ng antioxidant para hindi siya mag-oxidize. Oxidation kasi is the #1 cause of product degradation. Madaling ma-destroy yung ating mga drugs, yung mga pharmaceutical preparations natin kapag nag-undergo siya ng oxidation. Remember, oxidation is the addition of oxygen. Pag na-expose yan siya sa air, syempre the air contains oxygen, pwedeng masira yung ating mga drugs. So kaya nilalagyan natin ng antioxidant para hindi siya masira. Okay? One example is the sodium bisulfite. Meron din tayong antioxidant kino-consume natin. Tinitake talaga natin as purely antioxidant, just like vitamin C. Kasi meron din tayong mga oxidation processes inside the body. And yung oxidation processes na yan will lead to the formation of free radicals. Yung free radicals na tinatawag, yan yung mga causes ng ating condition, sakit, like cancer, for example, it's caused by free radicals. Free radicals, again, are product of oxidation. So, kaya nagko-consume tayo ng antioxidant. By the way, free radicals also cause the signs of aging. Okay? So, kanang mga eye bags, mga signs of aging. If you know, mga wrinkles, ganon, free radicals yan siya ang cause. So, meron tayong mga antioxidant like vitamin E, for example, antioxidant din ang vitamin E, na ang kanyang target is doon sa signs of aging. Kaya yung vitamin E, mina-market yan siya, di ba, guwapa. Okay, antioxidant din yon. Pero sa pharmaceutical na side, yung talagang gagawa tayo ng drugs, antioxidants are used to prevent product degradation by oxidation. Okay? Sige, questions or clarifications? Wala, kaya pa. Daghan na ka ito, no? Daghan na kayo mag-isulod sa inyong brain cells. So we need a lot of storage. Do not kill your neurons. Okay, another thing, sodium carbonate. Iba ito ha, kanina sodium bicarb yun, NaHCO3. This time, it's sodium carbonate or Na2CO3. Parehas sila actually ng gamit ng sodium bicarb. So, antacid pa rin siya, carbonating agent pa rin, both has sa industrial ug sa pharmaceutical na areas. Pwede pa rin itong gawing carbonating agent to make our carbonated drinks. Pwede din itong carbonating agent to make our pharmaceutical preparations. And then alkalinizing agent din siya sa Benedict's solution para maging basic yung ating Benedict's solution. Pero class, we have different forms of our sodium carbonate. Meron siyang sodium carbonate lang talaga. We call that anhydrous soda ash. Wala siyang water. So, sa kanyang crystals, walang water na naka-embed doon. So, anhydrous siya, soda ash. It's soda ash kasi pag sinabing sodium carbonate. Now, meron tayong mga sodium carbonate na sa kanilang molecules, sa kanilang crystals, may naka-embed na mga water. So, kung gaano karami, nakadepende na yon. Meron tayong sodium carbonate na merong 2 water molecule na kasama. We call that trona. And then, sodium carbonate na merong 10 water molecules. We call that the washing soda, the soda crystals, or the sal soda. So, iba-iba sila ng name depending kung ilang water yung naka-embed sa crystals. Actually, meron itong 7 din. 2, 10, and then 7. Yan yung mga possible na and existing na crystals ng sodium carbonate na merong water. 2, 7, and 10. Okay? So again ha, pharmaceutically, we use the sodium carbonate also as carbonating agent for our effervescent preparations. So, na-mention ko na ang effervescent preparation a while ago. Pwede mong gamitin ang carbonate, pwede ding bicarbonate. Pero pag gumawa kasi tayo ng effervescent preparation, it's not just the carbonating agent. Meron din yan siyang acid na component. So ito yon, organic acids. Organic acids ang ginagamit to make the effervescent preparation. Pwede siya tartaric acid, citric acid, malic acid, or even ascorbic acid. So yung for example, Berocca. Berocca contains minerals, it contains vitamins, but para mabuo ang Berocca, kailangan mo ng either carbonate or bicarbonate, and kailangan din yan ng organic acids. But what you need to know, class, if gumamit ka ng tartaric acid, kailangan sabay talaga yan sila ni citric acid. Hindi pwedeng tartaric acid lang or citric acid lang. So yung magiging effervescent preparation, tartaric acid plus citric acid plus the carbonate or the bicarbonate. Depende na kung ano yung gagamitin. Ganyan yung mostly sa effervescent preparation natin. Now, bakit kailangan sabay? Kasi pag tartaric acid lang ang ginamit mo, the effervescent preparation will easily crumble. Madali siyang masira. Masyado siyang dry. So, madaling masira yung, for example, tablet mo will easily crumble pag tartaric acid lang ang ginamit. So, kaya dapat sabay sila ni citric acid. Now, pag citric acid lang talaga ang gagamitin mo din, the effervescent preparation is very sticky. So, how are you going to remember this one? Tartar, pag na-tartar imuhang hipon,